Hi students, welcome back to the online classes. This is the second session of the chapter friction. So, in the previous session we have learnt about static friction. So, static friction is the frictional force which comes into play when there is no relative motion between the surfaces. So, the last session we have discussed an example. You are trying to push a luggage box. So, you have applied a 1 Newton of force here. But this block does not move. So, which force is opposing your force? You have applied 1 Newton. So, what is the force opposing your force? It is the frictional force, that is. So, even this box, even the surface of this box is in rest. There is no relative, this is at rest position only. Of course, you have applied 1 Newton of force. So, this box does not move. Why? Because this is a very heavy luggage box. So, 1 Newton of force is not enough to move this object. Let us say, to move this object, you need to apply 5 Newtons of force. To move this luggage, you need to apply 5 Newtons of force. But how much force you have applied? Only 1 Newton of force was applied. So, this block does not move. But what happens to your 1 Newton of applied force? There is a static friction. So, this static friction value becomes 1 Newton. The static friction value becomes 1 Newton. So, this 1 Newton of force and your 1 Newton of force gets cancelled. Here I was applying two equal forces. If this force was greater, it will move in this direction. If this force was greater, it will move in this direction. If two forces are equal, the block will be at rest. So, if you are applying 1 Newton of force, the static friction value becomes 1 Newton. So, that is why the block does not move. If you apply 2 Newtons, then the static friction value becomes 2 again. That is why we will call this as self-adjusting friction. In the previous class we have learned this. We will call this as self-adjusting friction. The value of the static friction value depends on the applied force, self-adjusting friction. So, after and 5 Newtons is the maximum static friction. If you apply 5 Newtons, the block starts moving. Then there is no relative motion between the surface of the box and the plane surface. If the box starts moving, so initially I have applied 1 Newton, it does not move, 2 Newtons does not move, and 5 Newtons, it starts moving. The block starts moving, and when the block starts moving, there is relative motion between the surface and the block surface. So, when the block comes into motion, when there is relative motion between the surfaces, there the friction is called as sliding friction. So, up to maximum friction, there will be a static friction applies here, static friction plays here. When the block starts moving, which type of friction will be there? There will be sliding friction. So, the friction which comes into play when there is relative motion between the surfaces. Friction which comes into play when there is a relative motion, when the block starts sliding, then this block is in motion with respect to the plane surface. Now, this is not at rest. When the block is at rest, the static friction will present between the two surfaces. When the block is sliding, which friction will present? Sliding friction will present between the surfaces of wooden block and the surface of the plane surface. So, here friction which comes into play when there is a relative motion, between the surfaces. When there is the relative motion between the surfaces, which friction will act? Sliding friction. So, what is friction? So, friction is the opposing force between the surfaces in contact. Friction is the opposing force between the surfaces which are in contact. There are two types of frictions, static friction and sliding friction. Friction which comes into play when there is no relative motion between them. Of course, there is the luggage box is not moving, but which friction will be there? Static friction will be there. When there is no motion, when there is no relative motion between the surfaces, which friction will act? Static friction will act. When the object is in motion, then sliding friction will act. Friction which comes into play when there is relative motion between the surfaces is called as static friction. So, this is about friction and types of friction, that is static friction and sliding friction. So, let us learn about factors affecting the friction. What are the factors affecting friction? So, let us learn about So, now we will discuss about factors affecting friction. So, friction depends on what factors? Friction depends on what factors? So, let us discuss an activity. Create a inclined plane with wooden plank. So, this is the wooden plank. So, create such a inclined plane. So, create such a inclined plane on a concrete surface. So, you have created a inclined plane. Inclined means making some angle. So, you have created an inclined plane on a concrete floor. This is a concrete floor. So, release the ball from this end of the inclined plane. Release a ball from the end of this inclined plane. So, what will happen? This ball will roll through this inclined plane and stops at some distance. So, it was rolled along that inclined plane and came to rest at this position and stopped at this position. So, repeat this experiment and create this same inclined plane on a marble floor, this is the marble floor, and release the ball here. So, the ball will stop here. So, what you have observed? So, the same inclined plane in the both cases, but what you have changed is here you have concrete floor, here you have marble floor. So, in the case of marble floor, the ball travels larger distance when compared with the concrete floor. When compared with the concrete floor, the ball was stopped here only, but it has travelled a larger distance in the case of marble floor. Why this was happened? This is because you can say that concrete floor is very rough, sir. Concrete floor is nothing but a rough surface. Concrete floor is a rough surface, sir, and marble floor is a smooth surface. That is why it travels more distance. So, here it travels more distance means this smooth surface offers less opposing force. Here rough surface offers high opposing force. The ball experiences high opposing force, high amount of friction. If it is a rough surface, here in the both examples what you have observed is the friction value. The friction depends on the roughness of the substance, roughness of the surface. The friction depends on roughness of the surface. This is what we will call as nature of the surface. How the surface is, whether it is a smooth or rough, nature of the surface. If it is a rough surface, more frictional force will be there. If it is a smooth surface, less frictional force will be there. So, why the rough surface and why the rough surface offers more frictional force and why the smooth surface offers less frictional force? So, let us to learn about that, let us see. So, if you consider any surface, so you have considered a surface, and if you see the surface, there are many irregularities will be there on the surface. Even the marble floor, this is the, let us imagine this as the concrete floor, and the marble floor will have also small irregularities will be there. Any surface, of course, it appears to be smooth, but it will have some irregularities. Irregularities means it is not plain surface. So, if it is a concrete floor, more irregularities will be there. If it is a marble floor, irregularities will be there. Irregularities not zero. Even the marble stone or the tiles or any substance will create some friction, will offer some friction. So, definitely concrete or marble, both the surfaces will have some irregularities. So, if you move the wooden block on this irregular surface, this wooden block will also have some irregularities. This wooden block will also have some irregularities. So, the irregularities between these two surfaces, will interlock each other, This interlocking of irregularities on the surfaces will offer friction. Friction is nothing but opposing force. Why this ball experienced the frictional force is this ball is having some irregularities on its surface and concrete floor is also having irregularities. But when compared with concrete floor with marble floor, the irregularities are more and sharp in the case of concrete. Here irregularities are there, but when compared with the concrete, these irregularities seems to be less. These are not so sharp. So, the interlocking, why this roughness surfaces. So, every surface, whether it is rough or smooth, there are some irregularities will be there along the surface. So, when the two surfaces are in contact, these two surfaces will interlock each other. And offer some opposing force. These two surfaces interlock each other and offer some opposing force. So, this is the reason behind the frictional force applied by any surface. This is the reason between the frictional force between two surfaces. Here, what is the first affecting factor? Factors affecting friction is nature of the surface. Factors affecting the friction is nature of the surface. If it is a rough surface, it offers more friction. If it is a smooth surface, it offers less friction. Why this surfaces offers frictions? Because of the irregularities presented on the surface. The irregularities of the two surfaces will interlock each other. They will fit into each other. These irregularities fit into each other. This offers some opposing force. This is the reason behind the friction between the two surfaces. So, what is the first factor affecting the friction? The factors affecting the friction is, first one, nature of the, it depends, frictional value depends on the nature of the surface. Nature of the surface means it includes whether the surface is smooth or rough, nature of the surface. Let us find out other factor which will affect the friction. So, let us discuss some activity. So, let us discuss an activity. Let us consider a brick on a floor. Let us consider a brick. This is the brick, and tie a thread to it, and attach a spring balance attach a spring balance here. Attach a spring balance to the brick. So, you are pulling from this side, this is your hand, imagine. So, you are pulling the brick, in this direction through a spring balance, So, the spring balance will helps to find the applied force. So, what we will get from this balance? Spring balance consists of a spring. So, some readings will be there in this arrangement. This particular string, the string inside it will have some pointer. So, this pointer will be located, will shows the readings on the spring balance, a spring will be attached here. So, if you add some weight, the spring will stretches, or if you apply some force to pull this spring, and pull this spring, what will happen? This spring will stretches. There is an increase in the length of the spring. Thus, increase in length of the spring is proportional to the applied force. If you have applied more force, more length change will be there. Increase of length will be more. If you apply less force, increase of length will be less. So, if you apply force, this pointer will indicate the force value. What happens in the case of spring balance? Increase of length is proportional to, since it is a spring, if you apply more force on the spring, its increase in length will increases, its length will increases. If you apply less force, less increase in the length. So, increase of length in spring balance is proportional to the applied force, So, this spring balance will helps you to find the applied force. That is why you have connected a spring balance to the brick. So, what is the principle that works in the spring balance is increase of length is proportional to the applied force. So, this applied force will be given in this spring balance. So, you have attached the spring balance to the brick and start pulling the brick. So, exactly the brick will starts moving with some applied force. You have applied some force in this direction. So, when the brick starts moving, just slowly apply force, the brick does not move, just increase the force, again increase. So, slowly you have to increase the force. So, for which force the brick starts moving, just take the readings of that force, So, you can find the force value in the spring balance. You are calculating the maximum static friction value. So, you need to take the force value when the brick starts moving. So, initially you have applied some force, 1 Newton of force was applied, the brick does not move, 2 Newtons of force was applied, the brick does not move, 2.5 Newtons of force was applied, the brick does not move, 2.6 does not move, 2.8, it was started moving. So, note this value, So, this value, note this value and keep it aside. So, okay. So, that is the static frictional value. So, with the 2.8 Newtons of force, the brick starts moving. You can move the brick without any help of spring, but why you have connected spring balance? To find out the readings, you need to connect the spring balance. How can you know the force value? You have moved the brick, what is the amount of force you have applied? So, here as I can move this object, how much force I was applied? So, to measure that force, you have added spring balance. That is why this is the reason behind we are adding spring balance. So, now change the orientation of the brick. You have placed the brick such that its length is along the floor. Now, place the brick like this. Now, place the brick like this and repeat the experiment with the spring balance and find out the value. Repeat the experiment as we explained previously. So, repeat this experiment by keeping the brick like this. Again you will get for 2.8 newtons of force, the brick starts moving. Here you have applied, in the initial case you have applied, how much force you have applied? 2.8 newtons. Here also 2.8 newtons. There is no change in the frictional force. So, here what is the change in the two experiments? The change is, here the area of contact is large. This brick is attached to the floor with a large area. Here the area of contact is less. Here the area of contact is less. Area of contact less, area of contact is high. High amount of area is in contact with the floor. Less amount of area is in contact with floor. But what was the force you have applied? 2.8. So, of course, the areas in contact are different, but the same amount of force was applied. So, what this says is the frictional force does not depends on the area of contact. Area of contact does not affect the frictional force. Area of contact does not affect the frictional force. So, from this activity you can conclude that frictional force does not depends on the area of contact. So, I was not writing here, I was only listing out what are the factors affecting the friction. Area of contact does not affect friction. Area of contact or frictional force is independent of area of contact. Frictional force does not depends on the area of contact. Frictional force is independent of area of contact. What was the area it is in contact? It does not makes difference. So, that is why I was not writing here. Why? Because area of contact does not affect friction, but we may think that area may affect the frictional force. No, frictional force does not depends on the area of contact. So, keep that in mind, it is a very important observation. So, most of the people may think that if the area of contact is high, frictional force is high. No, it was not like that. Okay. So, let us see about another one. Let us see about another activity. So, the same activity, again consider a brick. This brick is having some weight, right? This brick is having some weight. So, this weight acting in the vertical direction and a normal force will act on it. So, the brick is not moving in this direction and hence normal force is equal to the weight. Normal force is equal to the weight. So, let us tie a thread. So, you have connected a spring balance. So, how much force you have to apply in order to move this brick? So, let us say you need to apply 2.8 newtons of force. So, the weight of the brick, let us say the weight of the brick is 500 grams. What is the weight of the brick? 500 grams of brick is there and you need to apply 2.8 newtons of force. So, again now consider two bricks. What is the total weight? 1000 grams. If there is one brick, 500 grams. Two bricks are there, 1000 grams of force will be there. 1000 grams. And what is the normal force here? Normal force is equal to 1000 grams. Normal force is nothing but sometimes it equals to the weight of the object. Normal force is equal to the weight of the object. So, now you have repeat the experiment with the spring balance. This is hand. So, okay. So, if you observe the readings in the spring balance, what you has to take, how you has to take the readings from the spring balance? When the bricks starts moving, slowly increase the force, the brick does not move. So, with which force the brick starts moving, note that force. Here, if you apply 2.5 newtons of force, the brick does not move. If you are applied 2.8, I was just taking this as an example, numerical only, example value only. So, this 2.8 newtons of force will makes the brick to move. So, this is the starting force. So, if you observe the readings here, if you apply 5.6 newtons of force, then the two bricks starts moving. Then the bricks starts moving. So, what was the result here? Here the frictional force value is 2.8, here the frictional force is 5.6. So, on which factor the frictional force depends? The frictional force depends on the normal force. The frictional force depends on the normal force. We cannot say it as weight. Frictional force depends on normal force. So, what are the factors, main factors affecting the friction is, one is nature of the surface and another one is frictional force depends on normal force. If the normal force increases, frictional force will also increases. So, but what is the important note point here is, frictional force does not depends on the area of contact and frictional force does not depends on the weight. So, with this session is completed. In the latter session, we will see about what are the advantages and disadvantages of friction and what is the liquid can offers friction or not. We will see about liquids, friction in the liquids, and we will discuss about how can we reduce the friction, what are the methods we can use to reduce the friction. Thank you.